In the late fall of 1888, the wind that came down from the high peaks of the Colorado Rockies was not a whisper, but a physical assault. It was a dry, scouring force that stripped heat from wood, stone, and men with equal indifference. In the fledgling mining camp of Promise Creek, perched at 500 feet, the sound of that wind was the sound of waste. It was the sound of heat, bought with backbreaking labor and expensive wood, being ripped from the poorly chinked log cabins and balloon-frame shacks that dotted the valley. Men huddled around pot-bellied stoves that glowed red, yet the temperature 3 feet away was barely 40 degrees Fahrenheit. They burned through 4, sometimes 5 cords of pine a week just to keep the frostbite at bay. Then, when the winds shifted in summer, they brought the high country's other great terror, fire. Embers, carried on 70-mile-per-hour gusts, turned the settlement into a tinderbox awaiting a spark. But while Promise Creek shivered and feared, one structure sat silent. It was set back into the leeward slope of a small rise, a structure more hill than house. It was topped not with cedar shingles, but with living sod, green in the summer, brown and dormant in the fall. The wind striking the camp seemed to flow over it, like water over a smooth stone. The fire, when it came, would pass around it. This was the home of Silas Vane, a man the camp regarded as half-mad, a hermit building a badger hole. Inside, Vane was comfortable. His small stove consumed a mere barrow of wood a day, and his internal temperature, logged meticulously, never dropped below 62 degrees. His design was not a cabin. It was a bastion, a low-profile, earth-bermed shell, built not of tradition, but of physics. What did this quiet outcast trapper understand about thermal mass, aerodynamics, and combustion that the engineers, carpenters, and seasoned miners, with their libraries of manuals, had failed to grasp entirely? The year was 1888. Promise Creek was a child of the silver boom, a raw, ambitious camp hacked from the lodgepole pine forest. It was a place of high risk and high altitude, where the environment was actively trying to kill the unprepared. The winters were brutal, with ambient temperatures plummeting to 20 degrees Fahrenheit, 29 degrees, for weeks on end, not accounting for the wind chill that could drive the effective temperature to 50. The air was thin, making labor harder and fires burn less efficiently, but the true enemy was the wind. The geography of the canyon created a natural funnel for downslope winds that roared through the camp, sometimes holding steady at 60 or 70 miles per hour for days. The conventional wisdom for survival in this new, harsh land was simply an amplification of the old. The camp's supervisor, Elias Thorne, a man of rigid principles and Eastern education, dictated the construction. He trusted what he knew, the classic American log cabin, a symbol of frontier resilience, and for the miners' bunkhouses, the new, fast, balloon frame construction imported from the flatlands. The manuals from the mining corporation in Denver, printed on crisp paper, showed detailed schematics: 12-inch diameter logs, saddle-notched, or 2x4 pine studs, 16 inches on center. The philosophy was simple: against the cold, build thick; against the elements, build fast. The log cabin was a known quantity. It was what their fathers had built. It was strong, it was traditional, and it was respected. For Thorne, the only variables were the thickness of the logs and the quality of the chinking. The balloon frame shacks, meanwhile, were a concession to the economics of the boomtown. They went up in 3 days and cost less than $100 in materials. The entire camp, a collection of 20-odd structures, was thus a monument to conventional thinking. Every building a proud, high-profile rectangle of wood set squarely against the mountain, daring the wind to strike. Elias Thorne's pride was the new company bunkhouse, completed in August 1888. It was a testament to the right way of doing things. It measured 40 feet long by 20 feet wide, designed to house 24 miners. It was built from the straightest lodgepole pine, logs averaging 10 inches in diameter, meticulously notched. The gaps were chinked with a mixture of clay and moss, a task that took 2 men 3 weeks. It featured a steep A-frame roof, pitched at a 12-12 angle, a design intended to shed the heavy mountain snows. That roof was covered in 3,000 expensive cedar shingles, imported by wagon from Denver at a cost of $75, nearly a fifth of the building's total $450 budget. The bunkhouse was a fortress, or so Thorne believed. The failure began not with a bang, but with a draft. The first serious cold snap arrived in November. The wind, hitting the flat 40-foot-long wall, did not stop. It found every microscopic crack. The chinking, dried and shrunk in the high-altitude sun, cracked and fell away. The wind pushed through the very logs themselves. To maintain a survivable internal temperature of 45 degrees, the 2 stoves at either end of the bunkhouse had to be fed 24 hours a day, consuming a staggering 4 cords of wood per week. The cost of felling, bucking, and hauling that wood, measured in man-hours, was astronomical. Men sleeping near the walls developed frostbite indoors. Then came the windstorm of December 2nd. Gusts were measured by the camp assayer, Mr. Arkwright, at 75 miles per hour. The steep-pitched roof, so perfect for snow, acted as a sail. It caught the wind, creating massive lift. The sound, the men reported, was like a freight train. Shingles were stripped from the roof and sent flying like lethal discs. The entire structure began to rack or twist on its foundation, shearing the stovepipes and filling the room with smoke. The men fled into the 10-degree F night. The bunkhouse, Thorne's fortress, had become an uninhabitable, fuel-hungry death trap, its structural integrity compromised by a force it was never designed to acknowledge. Silas Vane was not an engineer. He was, by trade, a trapper, a man who had spent 20 years disappearing into the landscapes others merely passed through. He was an Ohio native who had gone west after the Civil War, not for gold, but for solitude. His education came not from books, but from observation. He had spent 2 winters in the high plains of the Dakota Territory, not in a fort, but in a winter camp with the Pawnee. He had watched them build their earth lodges, semi-subterranean structures that used the planet itself as a shield. He saw how the circular, low-profile structures presented no flat surface to the relentless prairie wind, and how the thick, earth-covered roof provided a thermal mass that kept the interior a stable 50 degrees, whether the outside was 90 or 30. Later, trapping wolverine in the high Arctic, he learned from the Inuit the principle of the Karmak, a structure part sod, part stone, and part tent, built low to the ground to shed wind and use snow itself as an insulator. Vane learned a different philosophy. You do not fight the wind. You do not block the cold. You use the earth to insulate. You use the wind's own physics to flow over you. And you build only as high as you must. When he arrived at Promise Creek, seeking to trade pelts, he saw the camp's construction and shook his head. He saw proud, flammable boxes of wood, standing tall and arrogant, wasting heat at every seam. He chose his own spot, 300 yards from the main camp, on a south-facing slope with a good windbreak of rock behind it. He began not by felling trees, but by digging. The miners watched him, perplexed. Elias Thorne confronted him, telling him the company owned the land and temporary or savage dwellings were not permitted. Vane, a man of few words, simply showed him the title to his 5-acre claim, paid for in gold, and continued to dig. The miners called it Vane's Folly, or the Badger Hole. They laughed as he spent a month moving earth and rock, while they had raised a cabin in a week. Vane ignored them. He was not building a house. He was building an equation. The first construction was a prototype for survival. and to the eyes of the camp it was an abomination. Vane began by excavating a 16 by 16-foot pit 4 feet deep into the side of the hill. This was not a basement. It was the core of the house. The excavated earth and stone were piled nearby, sorted. He then used the largest fieldstones gathered from the surrounding slope to build a 24-inch thick retaining wall on the 3 sides buried in the earth. For the front, south-facing wall, he laid the stone with a tight, meticulous clay and sand mortar, leaving precise, small openings for a single door and 1 small window. This front wall was the only part of the structure that was built in the conventional sense. The back and side walls were, in fact, the planet Earth, which maintained a constant year-round temperature of approximately 50 degrees Celsius, 10 degrees. He was not insulating from 20 degrees Celsius, he was insulating from 50 degrees Celsius. The roof was the most radical departure. Vane laid 3 massive 10-inch timber beams, scavenged from a deadfall not freshly cut, across the 16-foot span. Across these, he laid 2-inch thick, rough-sawn planks. His one major purchased item, which he'd hauled from Denver, came next, a single large sheet of tarred canvas. He laid this over the planks, creating a waterproof vapor barrier, a concept utterly foreign to the other builders. On top of this, he carefully replaced the 18 inches of topsoil and sod he had first excavated. He watered it, and the native grasses, dormant, took root again. The final structure was jarring. It did not soar, it hid. It was a mound of earth with a 24-inch thick stone face. It looked, as one miner joked, like a crypt that gave up. Thorne declared it unhygienic and a fire trap, assuming the earth would rot the wood. Vane, knowing his tarred canvas separated the two, merely set about building his stove. The conflict in Promise Creek was not just about building materials, it was a fundamental clash of philosophies. Elias Thorne and the camp represented the prevailing 19th century mindset. Man versus nature. Their structures were an act of conquest. A thick log wall was a statement of dominance. A tall, steep roof was a symbol of presence. They believed strength was rigidity, and success was measured in how forcefully one could impose human will upon the landscape. They fought the cold with more fuel. They fought the wind by building thicker walls. It was a war of brute force attrition, and they were invariably losing. Silas Vane operated on an entirely different axis, man within nature. His philosophy was one of efficiency, aerodynamics, and resilience. He saw the environment not as an enemy, but as a set of physical laws to be understood and leveraged. He knew that wood, no matter how thick, is a poor insulator compared to trapped dead air, or better yet 4 feet of earth. The R value, a measure of thermal resistance, of a 10-inch pine log is roughly 8. The R value of 4 feet of packed earth, as Vane was using, is over 40. He was achieving 5 times the insulation with free material. He knew that a flat 40-foot wall, perpendicular to a 70-meter wind, creates a massive high-pressure zone, forcing air through every crack. His low-profile, earth-bermed structure, meantime, presented almost no flat surface. The wind, striking the berm, would compress, accelerate, and flow over the roof, an aerodynamic principle that would not be formalized by engineers for another 50 years. Thorne saw a hole. Vane saw a thermally stable, high R-value aerodynamic shelter. The arrival of Mr. Arkwright, the mining company's assayer, provided the first objective data. Arkwright was a neutral observer, a man of precise measurements, who carried a calibrated mercury thermometer, a barometer, and a notebook. He was dispatched by Thorne in mid-January 1889 during a blue norther that held the camp at a stable 15 degrees to 26 degrees for 3 days to document the untenable fuel consumption of the camp. Arkwright first visited the main bunkhouse, which had been hastily repaired with canvas and spare boards after the December windstorm. His thermometer read 48 degrees, 9 degrees, near the stove, but 34 degrees Celsius, 1 degree Celsius, in the bunks near the wall. He recorded the drafts as a constant, measurable breeze. He precisely logged the fuel. The bunkhouse, housing 24 men, consumed 510 pounds of wood in a 24-hour period just to maintain this miserable temperature. He noted in his log that 10 of the 24 men were suffering from severe respiratory inflammation. Reluctantly, Arkwright then proceeded to Vane's Folly, half expecting to find the trapper frozen. He knocked on the solid oak door. Vane, in a wool shirt, let him in. The change was instantaneous. There was no wind sound. There were no drafts. The air was warm and still. Arkwright's thermometer, after 10 minutes, stabilized at 65 degrees, 18 degrees C. Vane's stove, a small, efficient model he'd fashioned from a steel barrel and lined with fire clay, was barely ticking over, a small log smoldering inside. Arkwright asked to measure the fuel. Vane pointed to his wood pile. Arkwright weighed the wood Vane used in the next 24 hours, 70 pounds. The data was stark and undeniable. Vane's structure, holding 1 man, used 70 pounds of wood. The bunkhouse, holding 24 men, used 510 pounds. Per person, Vane was using 70 pounds, the bunkhouse was using 25 pounds, but Vane was maintaining 65 degrees. The bunkhouse was struggling to maintain 48 degrees. Vane's design was, by Arkwright's calculation, at least 400% more thermally efficient and infinitely more comfortable. Arkwright's official report to the Denver office was a quiet bombshell of data. To understand Vane's success, one had to look inside the design, to see the layers of defense he had engineered. It was not a sod house in the prairie sense. It was a multi-layered system. The first layer was the shell, the earth berming. The 4 feet of earth and 24-inch stone walls functioned as a massive thermal battery. In the day, the heat from the stove and the sun, hitting the south-facing stone, would slowly absorb into the mass. At night, as the air temperature plummeted, that mass would radiate the heat back into the living space, stabilizing the temperature. This thermal mass, or thermal flywheel effect, meant Vane's stove was never fighting a cold start in the morning. The structure itself never dropped below 55 degrees, 13 degrees. The second layer was the roof, which Vane called the lid. The 18 inches of sod and topsoil provided not just an R value of 1520, but a critical fireproofing. Unlike a dry cedar shingle, the living sod held moisture. It was, in effect, a non-combustible material. A grass fire or even embers from a forest fire would scorch the grass on top, but would be unable to ignite the earth layer or penetrate to the tarred canvas and wood planking below. The third layer was aerodynamic. Vane had intentionally built his single thimble chimney stack short and placed it near the rear of the roof. When the heavy winds flowed over the sloped berm, the airflow accelerated, creating a low-pressure zone, a Venturi effect, directly over the chimney. This low pressure siphoned the smoke out with extreme efficiency, making his stove burn hotter and cleaner with less fuel, while simultaneously preventing downdrafts from blowing smoke back into the room, a constant plague in the other cabins. Finally, the system's weak points were addressed. The single window and door were not flush with the exterior, but set deep into the 24-inch stone wall. This reveal protected the wood from direct wind, rain, and most importantly, radiant heat and flying embers. The entire design was a quiet masterpiece of applied physics built with almost no money. The true test of the two philosophies, Thorne's brute force versus Vane's resilience, came not in winter, but on August 14th, 1889. It had been a tinder-dry summer. 3 weeks with no rain, combined with temperatures in the 80s, had cured the high country forest to a dangerous, explosive state. At 1:00 p.m., a dry lightning strike ignited a ridge 5 miles upwind of Promise Creek. Within an hour, The afternoon downslope winds, gusting to 60 miles per hour, turned the blaze from a forest fire into a firestorm. A wall of flame 200 feet high began to race down the canyon. Panic erupted in the camp. The alarm bell rang, but there was nothing to be done. The fire was moving faster than a man could run. Thorne, Arkwright, and the others grabbed what they could and fled, not to their cabins, but to the relative safety of the creek bed. The fire's vanguard, a storm of superheated embers and burning branches, hit the camp before the main wall of fire. The bunkhouse, its cedar shingle roof tinder dry, ignited instantly. Arkwright, watching from the creek, timed it. From first ignition to total roof collapse was 12 minutes. The radiant heat from the bunkhouse alone was so intense it ignited the adjacent company store before the flames physically touched it. The balloon frame shacks, built of thin 2x4s, were consumed in less than 5 minutes, vanishing like paper. The camp, Thorne's monument to conventional building, was gone in 20 minutes, reduced to a field of smoking foundations. The firestorm roared on, approaching Vane's folly. Silas had seen the smoke plume. He did not run. He pulled his heavy door shut. He closed his single window shutter, which was backed with a sheet of salvaged steel. Then he sat in the darkness and waited. The fire hit his structure. The 60-mph wind carried the flames horizontally, washing over the mound. The living grass on his sod roof scorched, blackened, and died, but it did not ignite. The 18 inches of earth insulated the wooden beams below from the 500-degree inferno, passing just feet above them. Embers, thousands of them, struck the 24-inch stone facade and died, finding no purchase. The wind, finding no flat surface to gain purchase on, simply rushed over the top. Inside, it became oppressively hot, the air temperature reaching 90 degrees, 32 degrees. The structure was a convection oven, but it held. When the firestorm had passed, leaving a blackened, apocalyptic landscape, the 30 survivors of Promise Creek emerged from the creek bed, choking on smoke, some with minor burns. Their world was gone. Every building, every piece of food, every tool was reduced to ash and charcoal. Then Thorne looked up the slope. Through the haze, he saw it. A blackened, scorched mound, smoking slightly, but standing. Vane's badger hole, the only structure left in the valley. They stumbled towards it, a procession of the defeated, led by the humbled Elias Thorne. Vane opened his door. The interior was hazy with smoke that had seeped in, but it was intact. His water barrel was full. His food stores were untouched. That day, Vane's shelter, designed for 1, became the command center and hospital for 30. Vane, the quiet hermit, took operational control. His discipline was absolute. He managed the single most important resource, air. The structure was hot and full of smoke. He used the chimney flue and the door, ordering them opened only when the wind shifted, to create a cross breeze that cleared the air without letting in the still dangerous hot embers. He rationed his water. Arkwright, the technical observer, now became the de facto medic, tending to burns with Vane's stored lard and clean rags. For 48 hours, the 30 survivors huddled inside the 16 by 16-foot structure. The thermal mass that had kept Vane warm in winter now served to keep them cool, the earth absorbing the residual heat of the fire-ravaged landscape, keeping the interior survivable. The aftermath of the fire was a stark statistical reckoning. Arkwright's report to the Denver headquarters was not a suggestion, it was an indictment. He catalogued the losses, 14 structures destroyed, including the $450 bunkhouse and the $200 company store. Total losses were estimated at over $5,000, not including the 6 men who died, trapped in a collapsed mine entrance they had fled to. The cost in human life and capital was catastrophic. And then there was the single entry on the asset survival log. Structure 15, vein S, dugout, stone sod. Cost, Est35, damage, scorched sod, superficial. Status, 100% operational. The numbers were impossible to ignore. Elias Thorne, his arrogance burned away with the rest of the camp, formally requested that Silas Vane supervise the rebuilding. Vane, seeing the desperate need, agreed on one condition: they would build his way. The Vane Bastion, as Arkwright dubbed it in his report, became the new company standard. Thorne, once Vane's greatest skeptic, became his most fervent disciple, working alongside the miners, digging into the hillside, learning the principles of thermal mass and non-combustibility. News of the fireproof, windproof cabins of Promise Creek spread. Homesteaders in the plains of Kansas and Nebraska, who lived in constant fear of tornadoes and prairie fires, began adopting Vane's principles, modifying their soddies with stone facades and deeper-set foundations. The railroad, looking to build durable, low-maintenance housing for its section crews in the high mountain passes, sent an engineer to study Vane's design, and the Vane dugout became a template for high-altitude railroad depots. A visitor to Promise Creek in 1895, 7 years after the fire, would not have recognized the place. The camp had been rebuilt, but it looked different from any other American boom town. The structures were not tall and proud. They were low, set deep into the south-facing slopes. The roofs were not shingled, but were green with native grasses and mountain wildflowers. The town seemed to have grown from the landscape rather than being forced upon it. The new bunkhouse, housing 40 men, was a long, low, earth-bermed structure that consumed 70% less fuel than its predecessor and had survived 3 major windstorms with 0 damage. Silas Vane's crazy design had become the regional vernacular. The Great Fire had not been a tragedy, but a lesson written in flame. It taught the settlers that the building methods they had brought from the wet, forested east were a fatal liability in the high, dry, windy west. Vane had not invented a new material. He had simply listened. He had understood that in an environment of extremes, survival does not depend on fighting the elements with more force, but on designing a system that makes force irrelevant. True strength was not in the thickness of a wall, but in the intelligence of its design. He proved that to withstand the fire and the wind, one did not need to build a fortress, but merely a shelter that was smart enough to let the storm pass by.